Here we go.
Screen. Let's get this thing up here. Good evening, everyone. This is Thursday, August 12th, 2021. It's the Great Lakes Renewable Energy Association's Clean Energy Seminar. Tonight, we're going to be talking about geothermal heat pumps for Michigan, and it will be presented by Allan Waller. He's the Territory Manager of WaterFurnace International. He's a member in good standing of the Michigan Geothermal Association and a member of the Great Lakes Renewable Energy Association Board of Directors. His phone number there and email are at the bottom there for those who would like to follow up with Allan after this presentation. My name is Mark Clevey. I'm the Vice President of the Great Lakes Renewable Energy Association. Our financial sponsors tonight are the Michigan Department of Environment and Great Lakes and Energy, or EGLE, and McNaughton McKay, a solar company in Ann Arbor.
Can I make a request that you put? Can I request that you put the email and phone number in the chat so we can just copy it easily?
I will do that. Yes.
Thank you.
We are celebrating our 30th year anniversary this year, and Great Lakes Renewable Energy Association is a 501c3 nonprofit. We were formed in 1991, and we are supported by members to educate and advocate for renewable energy in the Great Lakes area. Our Great Lakes Zoom programs, our Clean Energy Seminar is one of 4 programs that happen every Thursday. First Thursday of every month is Ann Arbor Solar Stories, hosted by Julie Roth, who is a manager of Solarize Ann Arbor. These are case studies on solar systems specifically in Ann Arbor, exclusively in Ann Arbor, I should say. Second Thursday of each month, I do the Clean Energy Seminar. The third Thursday of each month is Detroit Solar Stories, hosted by Diane Van Buren, who's a member of the GLRAA Board of Directors and president of Zachary & Associates, a development, financing, and planning consulting firm. And that also focuses exclusively on solar case studies in Detroit. And then the fourth Thursday of each month is My Solar Stories, hosted by John Sarver, which does case studies of meritorious solar projects all around the state. Our Clean Energy Seminar series covers topics of particular interest to clean energy users, businesses, advocates, and stakeholders. Seminars include content ranging from technology to business to public policy. Tonight, we're going to talk about technology. CES is a Zoom event. Again, it's held on the second Thursday of each month from 7 to 8. Any questions or comments you can direct to me. My email is there at the bottom. We ask you to mute yourself now and hold all your questions until the end of the presentation. You can raise your hand under reactions, and then I'll call on you so that we'll probably move some questions along quicker because we need to and want to get to everybody. There's the ways you can help GLRAA, and we ask that you do so, please. One, if you haven't already, please renew your membership in GLRAA. And if you haven't joined, we hope that you will take the opportunity tonight to do so. You can also financially sponsor a member in GLRAA, for example, a local teacher or a student. We've had several people now sponsor students from their local schools and local junior college, and we thank them very much. You can help us grow our membership by encouraging others to join. The more, the bigger, and the better we have our members, the more we can do. And last of all, you can make a financial donation to GLRAA by contacting Executive Director John Freeman. So it's my sincere pleasure tonight to welcome Allan Waller, who again is the Territory Manager of WaterFurnace International, member of the Board of Directors of GLRAA, and a member of the Geothermal Association. Tonight, Allan will discuss how the viability of geothermal heat pumps for Michigan. Geothermal joins solar, wind, biomass as a preferred renewable energy source in Michigan. Rather than using the sun's energy directly, however, geothermal uses heat from the Earth's interior, the original furnace. As with other renewables, geothermal is well positioned as a viable solution to climate change risks, lack of energy supply diversity, and economic development diversity and prosperity. Unfortunately, geothermal is also subject of the war on renewable energies by those seeking to reposition climate change risk as theory and not fact. Good news is that group is shrinking rapidly. But not soon enough. Hence the reason we need to get the word out about great technologies like solar, wind, and tonight, geothermal. So Alan, I want to welcome you to GLREA's Clean Energy Seminar, and we look forward to your presentation. You can take over the share screen now.
Thank you very much for that introduction. Can anybody hear me right now?
We can hear you fine, Alan.
Okay, great. Great. And I'm just going to go to a full screenshot.
There you go.
And this is introduction to geothermal heating and cooling systems. Basically, we are using the sun that heats the earth, and we are able to draw that heat from the earth. Just to get this good start off here, just as an introduction, when he mentioned earlier that we're using the interior, earth temperature, in some regards we might, but again, the sun is heating the earth on a daily basis. And even in the winter time when it's cold outside, that ground is still absorbing some of that sun and earth and the energy from the sun. So when we do a vertical loop and go 200 to 300 foot down, yes, the ground temperature is more constant and more consistent. And I agree that we are using some interior part of the earth crust and energy that's there. So it is internal energy also, but a majority of it, when a loop is horizontal or laid in a pond even, again, it's the sun. We're still picking up solar energy, which is a big benefit for everybody. And it's just transferring the heat and not producing it. So introduction to geothermal. Brief history. They recorded geothermal systems back in 1912. That was a Swiss patent. Edison Electric Institute sponsored closed loop research back in the 40s and 50s. And they were doing closed loop systems back in the 70s. The company I work for, WaterFurnace International, they've been in business since the mid and early 80s. And they've been a leader in the industry with technology, innovation, and training, and everything that's needed to make sure you have a good, viable system. What it does come down to, it's about transferring heat, and it's the thermal conductivity and the heat of transfer, where hot moves to cold. And if you can have a system that producing 10 to 15 degree temperature difference, either through the fluid that we're running through the loop or from an open water loop where it's a pump and dump, there's a great amount of energy to be exchanged or transferred. In fact, it's 400 to 500 times more efficient than a gas fossil fuel appliance would be. So there's some organizations. We have the ICSPA organization, and they were based out of Oklahoma and the college there, and they've done a lot of research and helped build our industry with the training and doing the thermal conductivity testing and making sure that loops are sized properly to the systems and the BTU loads. But basically, we're trading off electric, we're using electric, and we're gaining BTUs. And basically, they say 60 to 70% of the energy we use daily is to keep us comfortable, either our houses, our homes, and our businesses. So they do have. So now we're using like a low temperature geothermal, where they do have high temperature geothermal too, and that'd be out in your hot springs and geysers and so forth, where they are trapping that energy and doing more with that type of energy and transferring it into, making turning turbines and actually generating that electricity. But we're using a low temperature type geothermal where we're using the shallow earth temperatures. And what makes that such a viable thing, especially in the heating season, is that earth always stays at 50 to 55 degrees.
Good.
But actually, when I go further up north and we do our load calculations on a Geolink program, I'm seeing that we're using earth temperatures up north, let's say north of Traverse City, about 45 degrees is what, compared to down here is like 50 to 52 degrees. So we do take that in consideration of how the earth and the different temperatures of the climate of how far north you really are. So we have a water to air or water to water systems, where a water system would be similar to a boiler. And we're connecting it to a plastic pipe buried out in the earth. And basically, or you could put it in a pond, or you put a lake plate in, or again, do open loop where it's pump and dump. As long as you have good, clean water that doesn't build up scale or minerals. And again, all we're doing is transferring heat. So it's a big solar collector. The Earth is. It's storing our heat energy, and then air temperatures may fluctuate. So, like an air conditioner in the hot summer, humid days right now, we're getting rid of the heat in the home, and as we're discharging in the air product, it's hot air. We're trying to discharge hot temperature in the hot air. Air conditioning. I'm gonna brag about this. My cooling bill in a 3,000 square foot home, and it's calculated and monitored on our Symphony system, is about $25 a month here during these hot days and winter or months. Yet I'm using more electric in the summer, in the winter for my heating, but in the summertime, oh my gosh, the cooling, and it's great for the power companies because it helps reduce peak demand. But outdoor air temperatures, when you need an air conditioner to be most efficient, it's not, because it's hot and humid, and it's hard to get rid of that heat that we're working with. So we're using the heat as a heat of extraction for the heating. So we're pulling heat from the earth, and then in the cooling season, we're doing heat of rejection, where we're rejecting the heat back in the earth. And that's our source, is what we're getting from the earth. And then when we do our sink, is what we're pulling from the loop and bringing into the home. So we can put the loops horizontal, vertically, or lay them in a pond. We do use antifreeze in the system, and it's usually about 10% of the system. A 4-ton system, which is like 48,000 BTUs, would have about 4 circuits, maybe 400 to 600 foot in length in plastic tubing, and might hold around 100 gallons of water. And at that point, you're using about 10 gallons of ethanol, or you could do it all in glycol, also food grade, safe type of product with glycol. But also with the mixture of ethanol, it's not very harmful at all if you did have a leak, and it does evaporate. But it is one of the best ways to keep your loop median from freezing and still have a really good heat transfer. And that's happening what we call in the coax heat exchanger on inside the unit. So we have a distribution circuit. That's where we're moving the water solution in the loop area out into the unit, into the house. And then we have a refrigeration circuit that transfers that heat and brings it in to a higher temperature for heating, or again, rejects it for cooling. And with refrigerant, if not everybody knows how a refrigerator works, we're actually just removing heat from the space. So the evaporator inside your freezer takes liquid refrigerant and then atomizes it to a fine mist. And then when refrigerant is a fine mist, it absorbs the heat. So as we absorb the heat in that space, that gas then is compressed in the compressor, and it's condensed back to a liquid, which is your condenser back underneath the refrigerator or behind your refrigerator. And then that's where we reject the heat. So refrigerant in a vapor state absorbs heat, and refrigerant in a liquid state rejects the heat. And that was philosophy and invention of Mr. Carrier, basically, who's one of the gentlemen that patented that type of system. But then we could also take the heat that we're rejecting from the house for air conditioning, and we could apply that heat to the hot water and give you free hot water. We call that a hot water generator. But also it generates hot water for during the heating season, but basically the geothermal concentrates and works mostly to heat the home. So we do sealed, we do transfer again the water that goes through the loop through the refrigeration circuit, which is called a coax coil. So this is kind of like a flow of how everything works. So you got your earth loop, and we got heat moving to the refrigeration circuit, and you got heat moving to the hot water circuit, and you got your distribution circuit. So it kind of all works in conjunction. So here's a diagram on how it works, and it's the red indicates warm and hot, and blue indicates cold. So we're pulling return air across the coil, and our supply air is coming out warm. We have our superheater connected to the unit, and we're pulling hot water back to the storage. And then here we go to our loop, and then we start picking up the heat in the loop as we come back in. And they're using a small little circulator pump. And if we had an open loop system, you'd be using your well pump, which is a 230 volt, half horsepower pump that does use a lot of energy. And we do go about 2 gallons per minute per ton. So if you had a 4-ton unit, average size of a unit, you're using 8 gallons a minute per ton, or as the unit's operating per minute. And if you think about it, that unit operates 2,800 hours a year. You're moving about 1.25 million gallons of water. So you have to have a place to dump it, either a pond, a dry well, or a lake. And you could go up to 10 tons of capacity into a public pond or lake. And we're using plastic piping that is similar. It's the for the loop material, it's fused together with the hot irons of 450 to 500 degrees. And it's similar of the yellow plastic pipe they use for natural gas piping when they're running that. So and a lot of the capacity and the efficiencies are based on what our temperatures and what loop we're working with. Or where at my house, I have 5 vertical bores, 200 foot deep. And I'm very fortunate that I hit the well dry, told me we hit probably 3 aquifers. So we have very good heat transfer in direct contact with the water. And I could see my loop temperature on a very cold day or a cold week during the middle of the winter get down to about 35 degrees. And then as it warms up to in the 20s or just below freezing even, and the unit's cycling a little bit more, I had my loop temperature come back to 41 degrees. So during the winter months, I saw my loop as low as 35 and came back up to 41, which there's that renewable heat that we're picking up always, constantly, 24/7. So they also compare our energy efficiencies now up against air-to-air products, where they use a SEER rating and we use a EER rating, which is an energy efficiency rating, and it's basically working what it is in full load. And that's for air conditioning. And then in the heating mode, it's called coefficients of performance. And you'll see that most geothermal units are anywhere from 3.5 to 5.0 coefficients of performance. And again, those standards are different for the air source, and that's seasonal energy efficiency ratio. It's a measure of a cooling efficiency over the entire cooling season. And then their heating side is called the heating season performance factor. And it's just measuring efficiency over the entire course of a heating season. So first and second law of thermodynamics, and it is conservation of energy. Basically, you can't get more energy out than you put in. And second law is heat energy flows from an area of high heat to an area of low heat. So you cannot stop that process. You can only speed it up and slow it down. And here's like our basic refrigeration cycle. And like I said, here is our evaporator. Here's our TXV that actually meters the refrigerant to the evaporator. And then we get into a low pressure state and we compress it to a high pressure vapor state, and it condenses back to a liquid. And we go back to a high pressure liquid to the TXV and back to the evaporator in a vapor aspect. And a lot of people don't understand how a refrigerator gets cold. They always, I just plug it in. But really, that's what it's all about. So here's our coaxial coil. And this is where our loop water and our refrigerant coexist with each other. And that's one of the reasons why they call it coax. So that's where we transfer that heat and cooling. when it's operating. And there's a reversing valve that then reverses the flow of refrigerant in the opposite direction, which then changes the evaporator to a coax or to a condenser, and the condenser to a evaporator. Then we do hot water assist, and again, we call that a desuperheater. And we're going to connect to the unit, and we like to go to a storage tank, because as a storage tank will hold that hot water, all that free water. As you start using hot water, it's already preheated and you're using a lot less energy. So you got your horizontal track loop here. We have our vertical loops, and we have an open loop pulling groundwater, and we have our pond loops. And they could also put lake loops in, or what they have a stainless steel type lake plate, they call it. And these could be also put in as a slinky. So let's say these loops here, maybe 150 feet long, and they got 2 pipes in there. You could actually maybe put 4 pipes in there. But also they'll lay a slinky pipe down in this trench, and that can actually hold more pipe in that space and still have a very good heat transfer. And we're using the polyethylene piping. Normally our size is 3/4 inch out in the loop area, and we come back to like 1.25 inches. But as the systems and houses are bigger, you got 3-4 systems, you might have 2-inch coming into the house. Or in a commercial application, I've seen as big as 12-inch main coming in from the different well circuits outside. They do a reverse return heading, and they do a reverse and a reducing header. So as they do our header out here for the looping, for each circuit, it's a reverse return. So how they're bringing the water through and then bringing it back. It mixes everything up good. And we also like to see as much air. They use a flush cart to fill that system up, and then also remove and extract any air that might be in the system. So it's a closed loop system. Once it's sealed up, ready to go, no leaks, we can guarantee that system for 55 years, or at least over 2 systems can be connected to that loop and continue to heat and cool for further. Now here they are showing like a reduced, like 8 to 12 circuits. So they are using 2-inch PVC or the PE pipe down to 1.25 inches, down to 3/4, down to the 3/4 circuits, you know. And again, that's just all about pump pressure and head pressure and working efficiently with our pumps, so we're not creating more energy trying to pump a system that has high head pressure. So here's all the different types of trenches they can do. And they don't like to go over 5 foot in depth, because they don't want somebody standing in that trench and have that trench fall down on them. They could staple it up on the sides, they can lay it down on the bottom, and then come across with maybe 4 to 6 inches of dirt, and then lay some more pipe on the back. Here's a slinky setup. Here's how they build this.
We seem to have lost Al. He's frozen up on my screen. I assume he's frozen on John Cyrus too. We may have lost Allan. Allan, you're on mute.
Now he's muted, right?
Allan, you're muted.
I'm back. I'm here. So
Keep going, Allan.
okay, yep. And here's our horizontal bore machine using that. So there's a lot less.
Alan,
damage
you
the
need to
yard.
share your screen, Alan.
Oh, sorry. What happened here? I got lost. Hang on a minute.
The last thing you were talking about was, here's the slinky, but we didn't see it.
Okay, I got it. Hang on. But I don't know how I got off the call. Hang on. Sorry about this. Can you see me right now? Yes, okay. But how come I can't share the screen? Hang on. Here we go. There it is. Share screen. All right, right here. You see my screen now?
We can see it.
All right, hang on. Sorry about this. I don't know what happened. So here's the slinky loop. And then they were doing horizontal directional bore. And that does get a little more expensive because they're charging us more to use that machine to do that. And the same thing with vertical bore. When they come out and do vertical, we're paying for a well guy to come out with a $750,000 machine to drill 200 foot down and, and drop our pipe in. And then our contractor comes back and digs horizontally and connects all that up, about 5 foot down. But they also use these coil pipes set up for horizontal pond or lake loops. And they'll use them in 300-foot coils and put spacers in between that and help, transfer heat more efficiently. Here's a big job going in a school. They'd lay that in a big pond. And here's the lake plate, Slim Jim. So they could lay that under their dock or something of that nature. Again, here's our vertical. And I have 5 vertical bores, 200 foot deep. So each circuit's only 400 foot of pipe. If I was going horizontal and I had the room to do it, I would have probably 600 foot of pipe in horizontal, just because of our constant earth temperature being at a deeper depth. So here's our closed loop system. We have our flow center over here. Our piping comes to the unit. We have our return air and our supply air. And I don't know what happened there. I just hit the button again. So here's our flushing and filling. They're using a flush cart. And we like to use as clean, best water you can. Some job sites might have dirty, hard water. And you might have to bring in a distilled water or spring water or filtered water even, or city water that's filtered. But you definitely want to fill your loop with a good clean water. And when I did mine, I went and bought 110 gallons of water. It was about 80 cents a gallon, but I figured I had good distilled water and I shouldn't have any troubles for many years to come. In the open loop then, pump and dump, they're using pressure regulators. They have a mechanical valve that opens and closes to allow the water to come through. And then they also isolate that so they can flush the system in case we have any minerals or buildup in our heat exchanger, our coax coil. So they do talk about the 1.5 gallon per minute per ton. And we like to see that maybe up to 2 gallons a minute in Michigan. And they're showing a pump and dump and discharging and into a lake or pond. So key benefits, energy savings. It's quiet, it's indoor unit, no outdoor condensing noise, less maintenance in the long run. We have a longer lifespan than outdoor equipment. Safe and clean, no flames, no fumes, no flues. Environmental friendly, it's carbon free, and we reduce the peak demands of electricity in the summer. Commercial, office space, retails, hotels, all of it. They're getting a lot more opportunities in the commercial industry. And what's really cool about a commercial job, you'll have a computer room that he needs air conditioning all year round. And then the outer office areas might need heating. And your loop will work in reaction to pulling heat from that air conditioning space for the computer servers and put that heat in the loop and then pulling that heat from the loop to heat the building. Or I like the idea of in C-stores or in convenience stores with coolers. We could pull heat from the coolers all day long, and that heat can be utilized then in the rooftop units for heating. Or in my situation, I'm using a water-to-water unit to heat my domestic hot water. So in the summertime, I'm putting heat into my loop, and I never seen my loop ever get over 65 degrees. But in the summertime, so every morning when we take showers, we're pulling heat from the loop and putting it into our hot water, which makes that loop even more efficient. And I think like in the southern climates where it's primary cooling industry atmosphere, like Oklahoma, Texas, all those areas, and they're cooling all the time. Well, they've had problems with getting hot loops where the ground's so dry and they don't have enough moisture, and they get hot loops up to 80 to 90 degrees, which is still somewhat efficient if the outdoor temperature is 110, but still, we like to have cooler loops than that. Also works for snow melt, in-floor heating, all that's any. And we have units up to 300 tons now. Excuse me. So they're saying installing a geo exchange system is reducing greenhouse gas reduction, is like planting an acre of trees or taking 2 cars off the road. Also reducing the amount of barrels of crude oil. And the ground absorbs 47% of that energy that hits the earth. And again, we're about 400 to 500 times more times efficient than any gas or fossil fuel appliance. Preventative maintenance, you're gonna check, look for any leaks or any connections that might have vibration or noise. And the same would you have with the furnace. You have a blower wheel, you got to change your filter, those kind of things. Again, after a year or 2 of operation, normally the loop should be repressurized, because during the cooling season, the loop expands during heating and it contracts during the cooling. So sometimes you might get a little air that might have built up in there and might get caught up where the pumps are, and it could cavitate a pump. Or again, we just want to make sure we're in that 30 to 40 pound pressure range of the loop with no water or no air at all in the water. So just do regular quarterly and yearly checks. Check the ground loop pressure, loop antifreeze. They're getting into semi-annual, but again, I'm seeing that stuff done basically semi-annually and annually. They got strainers you can put in the system to help catch any of the minerals or debris in there. And I'm down to questions. Anybody have anything they'd like to ask?
So if people would go to the reactions and raise your hand, and you'll queue up, and we can get questions going for Allan. John, Abraham, you want to go ahead? You got to unmute.
Yes, I'm interested in some financial overview of installations. What are we talking about?
Well, you know what? I cover the whole state of Michigan, and I'm going to say over on the east side of the state, the prices are a little more expensive, and it is just what it is. I mean, I cover the state of Michigan, and I got maybe 4 different areas that this guy in the southwest corner of Michigan, he might put a system in for about $18,000 to $20,000, 4-ton system. Actually, we were just talking about it today, a 5-ton system. He quoted a woman, and it was like 18 to 19 grand. And that was a complete closed loop, horizontal loop, set up and installed. And that job site's probably, I'll bet you a 40-minute drive for their company. But he could get it done in 2 days. And the difference is now I go to the east side, and a similar job, that might be priced out around $28,000 to $30,000. In Ann Arbor, it might even be more. It's ridiculous. And I'm finding out, like, I don't know, it's frustrating to see that, because we'd like to try to keep it as low as possible. But what it's coming down to is some of the well guys and the excavators, they're so busy doing their well work and other things, they're charging our geo guys more money to bring their trucks out to come and do the drilling. And then the market, I'm going to say the average 4-ton system should be around 20 grand installed. And then you get your 26% tax credit. So that's $5,200 off of 20 grand. Now you're at what, $14,800 for a geothermal system. If I were to go have a complete furnace and a top of the line air-to-air heat pump installed, and I checked with my wholesaler, my cost, I am a licensed contractor, my cost is $8 grand for that equipment. And if a contractor come out and put that in, I'm going to estimate that job would probably sell for about 15 grand. So you're getting that tax credit, which then makes it an even playing field for us to be competitive with the conventional system. And even if we were a couple $1,000s higher, you're going to recoup that within a couple years. Especially if you're over propane. Yeah.
Alan, do you find that local jurisdictions drive some of those prices with, everybody's got different zoning or different ordinances or different
sometimes, yes. Yeah, because sometimes you do, like Oakland counties, they're charging an arm and a leg to get these permits done, just extra fees and involved with doing the loops. But some of the other outlying counties or areas don't really charge for a loop permit. But also there are state of Michigan guidelines to do what we need to do correctly. And that's also when they abandon a well too, and how they close that off. And we don't want ground contamination. We don't want an aquifer getting contaminated or something of that nature. So they are using grout and sealing those up when they do a vertical bore and drills. And they have to be ICSPA certified and go through a training process, and should be renewed every 3 years for the ICSPA training, and have those credentials on hand.
So do we have other questions?
What's that?
Abraham, did that answer your question? Okay. Any other questions? Oh, please, Harvey.
Yeah, I like to work with, the accounts that I heard about. I understand you're in a 3,000 square foot house. What kind of lot are you on? Are you rural? Are you in a city? Where are you?
Actually, I am rural. I'm out in the outlying areas of Paw Paw, but I'm in a subdivision. So my lot, that I couldn't put a horizontal loop in because I have a septic system in the backyard, and then my front yard is about 140 feet by 70 feet to the road. And then I do have my well out front too, which we had to stay away from in regards, but I did put 5 vertical bores, and they're about 14 foot apart. So right across the front of my yard, that's, they came in, just drilled up. And what we were speccing when I did the Geolink program, it was recommending 180 foot deep. Well, the roll comes in 200 foot. So I just had them go to 200 foot, put the roll in, might as well. So I had that little extra bit because I wanted a little extra loop for my water to water unit. But yeah, I'm in a small, verticals can be put in almost anywhere as long as we get the machine in there. That's some of our problems in the Ann Arbor area. They want to go more geos and put vertical loops in, but we can't get trucks where, trees are in our way, or overhead power wires, or again, we can't get in the backyard. So we are looking and hopefully finding smaller type drill rigs that can handle, 200 foot, 150 foot down for residential applications. And if you had a 2-ton unit, you're only going to do 2 vertical bores.
So
in a 3-ton unit, we do 3 vertical bores.
So in light of that, you've said that this has been going on since the 80s. What kind of technological changes do you anticipate in the next 20 years to allow for all these encumbrances, like you can't get a machine in there, et cetera?
Good question.
There's a company out of Chicago called Chicagoland Geothermal, and he's got this machine that he designed and patented. It's called Rig in a Box. And he could bring that down in a basement, and this could be done with one guy, or actually 2 guys to set it up. But the one guy, once it's set up, he can drill right in the basement and drill right below the house itself, drill a hole in the cement floor, go ahead and set this up, and they'll go 100 foot down. And with one guy, they can do that. And they'll put maybe, 1 circuit for each ton of heating and cooling. And most of them are getting maybe 2 or 3 bores, maybe 4. But he puts the header right up on the sidewall and pipes it right in. So at this point, we're alleviating some of that added loop and added work that's involved of trenching and excavating and all that. So it's pretty neat system. But boy, he wants, I forgot what he wanted, $250,000 for this machine. And it's like, wow, and it is neat. But if you go online and you just type in Chicagoland Geothermal, or you could type in RIG, RIG, rig in a box, a box. And it's pretty cool. But also now we have a system that we come on board with a couple years back called Symphony. And with Symphony, we're monitoring systems right from the compressor to the wattages from the motors to complete energy usage of the unit itself. And I'm trying to find it. Here we go now.
So you're talking about a feedback system, like if you have solar panels, you can see how much you're producing every day.
Yes, you can see
every
actually, you're monitoring your system, how much energy used, how many kilowatt hours are being used. And then you could type in your cost of what you're paying. And gosh darn it, I don't know what happened to that. Hang on a minute. I had a quick link to that Symphony. Oh, I know. Hang on a minute. I'll go right to here.
So Al, while you're looking for this, we know what the utility companies think about solar energy in Michigan. What do they think about geothermal?
Well, DTE and the co-op electric companies all offer huge rebates to put geo in up front. And they also offer a separate meter rate to lower your cost of 25 to 30% on your electrical rate for geothermal, which in turn help them reduce their peak energy demand in the summer months, and they're rewarding you for that. Now, Consumers Energy doesn't offer any support at all. They do give a $300 rebate for a geo to geo replacement, but that is it. And but with the co-op electrics, they offer, like up in Traverse City area, Cherryland, they're offering $5,000 rebate to put geo in. It's phenomenal. But then some of the other ones offer maybe like $1,500 to $1,800 or a fee per ton. But then also like Traverse City Light and Power, they had a bunch of rebates set up for air to air, nothing for geo. And we just had a homeowner take out an old steam boiler, and they went ahead and they put in geothermal. And I saw they didn't have any rebates, and he went ahead and made some changes and updated that for us, and gave us that homeowner almost $900 in rebates from the electric company. So that was fantastic. I mean, and we're hoping to hopefully get out more opportunities of doing something like that.
Al, I've got a question.
Yes.
Al, you had said for a 3,000 square foot home, you were estimating around $25 per month in electrical costs during the summer.
Yes.
How does that compare? What sort of costs per month are you seeing during the winter months when the compressor is running?
Man, I'm on AEP, which is Indiana Michigan Power, and it's in the southwest corner of Michigan here. And when I first put my geo system in, I was at 10.5 cents a kilowatt hour. And when I did calculations over natural gas, I was saving about $900 to $1,000 a year. I'm at 16.2 cents a kilowatt hour now. I think I'm saving over natural gas maybe around $500 a year, but it's still a savings, and it's still a nice way of cooling and heating, and very comfortable, very quiet. But you were saying on my cooling cost, is that you were asking how do I, the heating cost. So I'm paying an average of $200. I pay a $200 a month bill to AEP. So I'm just flat across the board. And then I have my makeup month usually, and I think in May, and normally I'm getting my bills less. So I'm usually around that $2,100 to $2,200 a year, I think, in energy consumption. And that's gonna, and I want to share my screen here for a second. And I'm going to show you what we call Symphony. And it's gonna be, where is it? Right here, Symphony Insight. Now this program here, now we have over 9,000 units installed, WaterFurnace units with Symphony over the last year, right? I mean, we sell a lot more units, don't get me wrong, but over the last units that have been in operation for over a year, there's over 9,000 units. And set up at operating costs, I think this is set up around 12 cents right now. Excuse me. This would be the average cost of a home running on geothermal at 12.5 cents a kilowatt hour, $640 a year. So I'm going to go up here. I'm going to click on Michigan. And with Michigan, I'm going to pull up Michigan. Now I have over 517 installations. They're all dotted here in the blue dots, dark blue and light blue. And now for the average here, and I'm going to say again, I got to double check what my cost is over here. Operating cost of distribution. I think it's around, I think it's usually set at about 12 cents or so. Let me go back here. Boy, you guys heard my way. So what I can do now, once I click on Michigan, I can go to filters and settings. And now, yeah, here we are. We're at 12.5 cents a kilowatt. So I can say I have a 5 series, or let me, I could take and say I have a 5 series 2-stage unit. And I'm going to say it's going to be a 4-ton system. And I'm on DTE energy. So here's all those units that light up now. Darn it. So all these are the dark blue dots are the higher energy consumptions. The lighter blues are lighter. So they're telling me here on that 4-ton system, the average cost on it, I'd say a DTE customer is only going to pay about $766 a year in their heating and cooling cost. Now, if they were on consumers energy, we're actually, it should be about 19 cents, 11.64. That's the difference. And again, this is real true data, accurate is within 1%. But then I could go over here. Now I could click on one of these little dots here, and that tells me, now here's a 7 series, variable speed, 3-ton, annual electricity usage. This is actual usage taken every 10 seconds, and then annual electricity cost. And it's saying the total cost $217 a month for that unit. That must be a small home. They're not using very much power at all. But this is what's so cool about this. I can go in and show a power cup. So, or a homeowner. So let's go to the 7 series. I'm going to click on the 7 series, and that's our most energy efficient unit. It's a variable speed. We're at the 4-ton capacity. And I'm going to go back down to that 12.5 cents. And look at the difference now on the savings. It was about same price, $667 a year for heating and cooling. And now here's those units that have been sold and that light up. Now look at this area here, which is phenomenal. Mark Wurzel of WaterFurnace in Michiana. He's our largest dealer in Michigan, and he puts a Symphony on every job he sells. And that's why you see the corner of Michigan here, the southwest corner. Look at that, the dots and how it's so loaded up with his units, because he puts one on every unit. He sees the benefit of being able to service that unit, view the operation. Let's say there's a fault code that comes up, and it's a sensor for a drain, the drain tube. Well, the guy can send out a filter changer instead of his, $50 tech guy, But this actually is true data, true energy savings. And then cost-wise, when we do separate meter charges around that Detroit area, Ann Arbor area, the electricians are charging $3,000 to $4,000 to hook up that separate meter. And you go up lining areas here, Mark Wurzel, he says, I'm getting that done for $1,200. So that's the difference between, Southwest Michigan and, Ann Arbor and Detroit area. Oh, another one, a loop needed to be reflushed, and it was for Mark Wurzel's aunt and uncle over on the east side. And my dealer went out to do that. They got a bill of about, he would say about $900, but I gave a deal and it was $750. Mark says, I go out and do that for $350 all day long, So again, and then if I go up north, Traverse City is a high dollar market. And now I just got a nice order this past week for, there's 3 systems going in this house. There's two ladies that live there and they're on natural gas and they just want to be green. They want to be carbon free. They're cutting the gas from the house and putting in geothermal. I can almost guarantee that's over a $50,000 job going in. And I'm like, don't think twice now, because there's more and more people that want to cut the gas and don't mind paying that little extra to be carbon free and feel like they're contributing to our climate change and saving our earth. I mean, and that's what we're doing with renewable energy. So this is a cool program. It does work.
Let's say if somebody calls
It
you
is
up.
accurate. It's in with 1% of our Geolink program. So in the beginning of the process, one of our contractors will go into Geolink. He'll size the house for the BTU capacity, and then he'll go and pick a piece of equipment, and then he'll put in the parameters of what the loop type is going to be, if it's horizontal, vertical, how many circuits, and then he could see bin data and say, hey, at 15-degree outdoor temperature, my unit starts running at 100% of the time, and now I start bringing in electric strip heat for to help make up a little bit of this, and that normally comes into play late in the season because the ground, we pulled so much heat from the ground, our temperatures are a little cooler. But then that program tells me, oh, by the way, you're only using your electric strip heater maybe 50 hours a year. And you take 50 hours times, 12 cents.
Alan, we got some questions. Clinton's got a question for you. Clinton, go ahead.
Yeah, hi. I got a couple of questions.
Yes.
I'm in an area with very unreliable power, so need some kind of a backup
Generator.
when we fail. I got a couple more parts to that question.
Yep.
When the system is running, how many kilowatts per ton does the electric motor draw? And what's its duty cycle? Is it on all the time or part-time?
Would it be like when the unit's operating, you mean?
Yeah.
Well, now our 7 series, which is variable speed.
Just on a per ton, because I look like I would need 4 to 5 tons probably for this house.
Okay. And that, I'd have to go and dig up a little more information, but I want to give you an example. Now, our 7 series unit, which is a variable speed compressor, they're showing on startup amp draw in around that 10 amps. And with all the other things going on, I think they call it around 30 amps for startup.
Now, is that surge or continuous?
If you took a standard 2-stage unit and a standard scroll compressor on a 4-ton unit, your amp draw, lock rotor amps on startup is usually around 105. But
right, but what's running?
We have something called IntelliStart now, which lowers the start amperage by 60 to 70%. So now with our lock rotor being around 35 to 45 amps, you can have a lot smaller type of generator to power your system when you are down. I mean, again.
Right. I understand locked rotor, but what's your average running current? Or actually your average running watts?
Average running current, I mean, we're using, and residential is 230 single phase. And let me pull up a spec real quick. It will just take me a second here. I'm going to pull up a spec. And I'm going to pull up like a 5-ton unit, or like a 5 series. It's a 2-stage unit. It's most of our popular unit, basically. Specification.
And I put Alan's email and phone number in the chat room too, so you can send him your load or your specifications. He could probably get that to you.
Yeah, and I did too. When I was one of the first ones that put that in there. Let me look at hang on, electrical data here. Electrical data is page 31. Hang on a minute.
So we're running out of time here, Alan.
All right, but real quick.
There's a lady wants to know.
4-ton system. dual capacity. MCC is 33 amps, minimum circuit capacity, 33 amps. Rock loader amps, they're showing at 21.1. I mean, run load amps at 21.1, locked rotor at 104. And when you do a locked rotor amp with IntelliStart, it's at 37. They're showing the hot water generator pump at 0.4 amps, a loop pump at 5.4, blower motor at like 7 amps for a 4-ton. Full load amps on a unit is 33.9. Minimum circuit ampacity is 39.2. So, you're going to put a 50 amp fuse in there. But send me an email, give me some information, and I'll be glad to follow up with added data, whatever you may need.
So Allan, we got one final question here from Judith. And
Yeah.
the question is this: how long do these systems last, or do different parts have different times to be replaced?
Well,
Last question.
AHRI, American Heating Refrigeration Institute, has geothermal heat pumps at 24 to 25 years lifespan. Reason being, they're installed indoors. Some of the replacement parts and pieces might be a flow pump, flow center, standard thermostat. You do change filters regularly, but cost on one of the replacement pumps might be, a couple $100. Let's say you had an air coil go bad, those could get expensive, $1,000 change out, for an air coil. If a air coil drew a leak and you had a refrigeration leak in that thing. And now we're using aluminum coils, and we're having very few of those situations at all. It's been very dependable using aluminum for all aluminum coils now.
Super. Well, Allan, I want to thank you so very much. This was a really good, informative talk. We really appreciate the opportunity to see and learn more about geothermal. I can see there's some things we ought to be talking about in Lansing to get some consistency of how these systems are put in and across the state. Perhaps some of the Biden money could be used for the cities to get access, or at least pay some of the rental for the drilling equipment on horizontal wells in cities, and ways that we could move this technology along. It looks to me like there's a number of places where prices are driven up artificially for no good reason. And there's a lot of benefits that can accrue to communities by putting geothermal in, certainly on new construction. And I can think of lots of places in old construction. And as communities start thinking about trying to put in, more zoning and do regional microgrids and stuff like that, there's absolutely no excuse that geothermal shouldn't be a central part of that kind of thinking as they move forward. So with that, I want to again thank everyone. Again, if you are not a member of GLREA, we please ask you to please join. You can go to our website and join. Get your friends to join, get your family to join, get a student to join. And if you have some extra money laying around, John Freeman would love to get a tax-deductible charitable contribution to GLREA. We're a lean operation, but we're statewide, and we're doing education programs like this. We're trying to move the target. We're lobbying. We're doing everything we can to open up the market. And Julie Baldwin, our good friend at the Michigan Public Service Commission, she talks about speeding up the solar train. And she uses the word solar for our renewables. And that's what we're trying to do. So every penny you give us is used to buy fuel to speed up the solar train. So with that, John Freeman, got any closing remarks?
No, I just want to thank Allan. I want to thank everybody for joining us this evening. And this will be recorded. It will be on YouTube. So if you want to hear it again, or you have friends that want to learn about geothermal, encourage them to go on the GLREA YouTube page, and all our videos will be up there.
Again, thank you, everyone. Come back next month. We'll be doing